all partitions are equal and we are having a number of processes as per the processes which are eligible to keep into the partition. We can keep it, but we don't need to bother which partition you are going to choose to keep the process. Now in this case, since we are having the unequal size partition, and we are having the variable length of the process, so now we need to decide which process we are going to keep into the which partition. Okay, so in order to decide that one, we are going to use the algorithms. Okay, that algorithm is going to decide. Okay, so which partition you need to select, we need to keep the particular process. So those algorithms are first fit, best fit, next fit, and first fit. So let us see the first fit. Okay. So first fit is going to see. Let us assume this is the user area. From this user area, we are going to scan the memory location and for the particular process. Okay, if you got the enough room to keep the particular process, you are going to keep there only the process. Right? So you are going to keep there only the particular process. Now, what is the advantages and what are the disadvantages of this one is? Advantage is it is a very fast, since you are finding that wherever the memory location is there only you are going to keep. But what is the drawback here you see? Okay, for example, there is a process. Okay, there is a process. The process size is 5 MB. There is a process. The process size is 5 MB. Let us assume all these partitions are already full. Okay, only there is a one partition which is free. That is the 16 MB. When I am doing from first bit, okay, what I will do? I will start from here till this all the partitions are full, and I am going to get the free space here. So now when I am going to keep the P7 here, then what is the remaining space? Out of 16 MB, if I give the 5 MB, what is the remaining space? 11 MB is the remaining space. Now if you see here, this is the fastest one, but what is the drawback here? It leads to more internal fragmentation sometimes. I think fastest, but it is not feasible solution. Okay, so to save the memory or to reduce the internal fragmentation, that is the first bit. What about the next one? The next one is what? Best bit. So what we are going to see the best bit? We are going to scan entire memory location. We are going to scan entire user area, and we are going to see which partition is appropriate to the particular location. Which partition is appropriate for the particular process, or which partition is going to give the best space or best minimum best space. Okay, that partition only we are going to see. Let us assume. Okay, so if I want to keep the P7 process, what is the P7 requirement? 5. So let us assume they are all of the. Now you see, I am going to scan entire thing, and I am going to decide which is the minimum one, which is the best one to keep the P7. 6. This partition. So this partition is going to give how much space on wastage? 1. Whereas this partition is going to give how much space? 11. So now best fit is going to give minimum best of memory, and since this is going to give the optimal solution. But what is the drawback? It is going to consume more time, since you need to scan all the partitions. So it is going to consume more time. Okay, to decide which process we need to select. Okay, that's about the best fit. And what about the next fit? The next fit you can see the example. Okay, let us assume in the previous case. Okay, I stop the execution, or I use the partition this one. Where we use this is the P7. Now I want to keep the P8. So what I will use the next fit is, instead of scanning from here, what I will do? I will scan from where I stopped the last transaction, or where I stopped the last scanning. Where I stopped here, from this up till this I did, right? Till this, this is the last partition I use. From here I am going to scan. Instead of scanning from the beginning, I am going to scan from where I use the last partition, right? So now, what is the worst fit? Worst fit is the exactly opposite to the best fit. It is not going to select. Okay, with minimum. It is going to select, or it is going to give more waste of memory. Okay. So now, what are the drawbacks here you see? Okay. So till now, okay, we are discussing about the static partitioning as well as the static partitioning only we are discussing. In the static partitioning, we try to discuss about equal as well as unequal the equal partitioning, all the partitions are going to be equal. Okay, and whenever you want to keep a particular process, what you have to do? You have to see the partition size and the process size. Whichever the process is less than or equal to the partition size, that process only we are going to keep in the memory. If the process is having more size than the partition, that process we cannot keep. To keep the process, we are going to use the overlaying technique. What is the overlaying technique? Instead of keeping the whole program into the memory, you take the part of the program and keep it to the memory. You take the part of the program and keep it to the memory. So that is the overlaying technique. Overlaying technique can be easily implemented by the programmer, okay, without taking the help from the operating system. Then we came to the unequal size partitions. In the unequal size partitions, we don't have any equals and we did not be the equal size partitions. All partitions can be the unequal. But what is the question mark here is, the process are also going to have the various sizes. As per the sizes, which partition we need to pick up in order to make minimum waste of memory. So in order to do that one, to get that one, what we are going to use? We are going to use the placement algorithms. What are the placement algorithms? Best fit, first fit, next fit, first fit. And best fit is going to give the optimal solution, but it is going to time consuming. And whereas the first fit is going to follow the exactly opposite to the best fit, and it is going to give the more waste of memory. Okay, first fit is in the sense it's the worst the memory management uses. Okay, our memory uses. And the other one is the first fit. So in the first fit you are going to scan the memory, and wherever you find that okay it is going to be enough room, so there you are going to store, or there you are going to keep particular process. And what about the last one? Next bit. The next bit you are going to see like this. What is that? If you stop in the previously in one memory location, from that memory location you are going to scan instead of scanning from the top location or from the beginning. Okay. This is about the static partition. Can anyone tell internal fragmentation is the drawback? And the number of partitions and the number of processes all are fixed. Because if you see in the first case, how many partitions are there? How many partitions are there? 7 partitions are there. 7 into 8 how much? 56 MB. So 7 partitions are there. Each partition is 80. Now based on this, how many active process can be there in a memory locations at any instant? How many can be there? Only 7. Since we are in the 7 locations. It means what? Number of partitions as well as the number of processes are fixed. Okay, since 7 partitions, 7 processes. And one more point is internal fragmentation. So these are the drawbacks. Okay, we can stop. These are